Every time you type in a text field, 3 billion browser tabs quietly run a grammar checker on your prose. Grammarly, Microsoft Editor, LanguageTool, Google Docs, even the little red underline in your operating system's text field. Every one of them is doing grammatical error correction, and GEC is one of those NLP tasks that looks trivial and is actually terrifying. Welcome to Video 7 of Lecture 9. Automated Writing Assistance. Not just fixing typos, fixing grammar, suggesting style, rewriting whole paragraphs for tone, a single suggestion pipeline that runs on every keystroke for hundreds of millions of users. Under the hood, one of the more interesting recent architecture wars in NLP? Video 6 was sentiment analysis. Read text and label it. Today's task is different. Today we're going to change the text. Take an input string, produce an edited output string. That is a fundamentally different problem, and the way the field solved it split into two very different camps. Today's puzzle. What's the right shape of a grammatical error corrector? Two options are on the table. Option 1, a sequence tagger. Look at each token, decide whether to keep it, delete it, replace it, or insert something. Option 2, a sequence-to-sequence model. Read the whole input, generate the whole corrected output from scratch. Both work, they fail differently. Today's 3 beats. First, what GEC actually is. The task setup. The CoNLL LTWN 14 shared task. The taxonomy of English errors. Article, preposition, subject-verb agreement. Second, the architecture split. Sequence tagging with edit operations versus sequence-to-sequence generation. Why both are competitive and where each one wins. Third, the LLM twist. What happens to a well-scoped task like GEC when you can prompt a general-purpose model? And why Grammarly is still Grammarly? Beat 1. What GEC is. Given a sentence, possibly from a non-native writer, possibly full of errors, return a minimally corrected version. Everything that was wrong should be fixed. Nothing that was fine should be touched. In 2014, the CoNLL shared task made this a formal benchmark. Ng et al. Released a dataset of essays by English learners, hand-corrected by native speaker annotators. Every research group had a target to beat. Second language English errors fall into a small number of buckets. Article errors, a versus an versus nothing. Preposition errors, in versus on versus at. Subject-verb agreement, verb tense, noun number, spelling, word choice, word order. The distribution is heavily skewed. Article errors alone are 1/5 of the total. This means you can get a decent GEC system just by nailing a handful of categories. Grammarly's actual product isn't only GEC, it's also style, suggested rewrites, passive voice detection, tone adjustments, which means the underlying pipeline is a whole toolkit of models. A spell checker, a grammar corrector, a style engine, and increasingly, a rewrite generator. Every user keystroke pings some subset, and the UI's job is to surface only the most confident, least intrusive suggestions. Beat 2. The architecture split. Option 1, sequence tagging. GECToR is the classic paper here. Canonical and colleagues 2020. Look at each input token. Predict an edit label. Keep, delete. Replace with word X. Insert word Y before this token. Change to plural. Change tense. Apply the edits. Because the tagger only operates on tokens that are already there, it can't rewrite huge chunks. It's fast. And it's transparent. Option 2. Sequence to sequence. Yuan and Briscoe 2016. Treat GEC like machine translation. Input, the buggy source sentence. Output, the corrected sentence. A transformer encoder-decoder generates the target from scratch. This handles massive rewrites easily. Reordering, restructuring, splitting sentences, joining them. Trade-off, it's slower, it hallucinates confidently, and if the input was already correct, it might edit it anyway. The scoreboard on the BEA 2019 shared task. Bryant and colleagues' updated CoNLL is close between the two approaches. Tagging wins on speed and reliability. Sec2OSec wins on the hard cases requiring large rewrites. In production, most systems ensemble both, or run a tagger first for the common errors, and fall back to Sec2OSec for the ones the tagger can't handle, or route by confidence. Beat 3. The LLM twist. Prompt GPT-4 or Claude. Correct the grammar of this sentence and get a very good correction. On some benchmarks, straight LLM prompting beats every specialized GEC system. So why does Grammarly still exist? Because the constraints of a keystroke latency product are different from the constraints of an offline benchmark. Interesting design pattern. Modern writing assistants like Grammarly Premium use small local models for keystroke latency GEC, sequence taggers, distilled models. Then send longer text to a cloud LLM for style rewrites and tone adjustments. Two-tier architecture. Fast local model catches typos and simple grammar. Slow cloud model does the paragraph-level thinking. Best of both. The subtler problem. Writing assistants change how people write. Every non-native speaker who uses Grammarly ends up sounding more American. Every prompt of, "Make this sound more professional," pushes toward a specific tone. There's a research question quietly emerging. What does it mean for language to be shaped by a small handful of correction models? That's Lecture 10 territory. For now, the technology works. The consequences are still landing. 3 takeaways before the quiz. 1. GEC is text-to-text editing, not classification. CoNLL 2014 Ng et al. Made it a formal benchmark. English learner errors are heavily skewed. Articles and prepositions dominate. 2. Two architecture camps. Sequence tagging with EditOps GECToR 2020 versus sequence-to-sequence generation Yuan and Briscoe 2016. Tagging is fast. Sec2sec handles rewrites. In production, both. 3. LLMs beat specialized GEC on quality but lose on keystroke latency and cost. Grammarly scale products use a 2-tier stack. Fast local tagger plus slow cloud LLM, and the tools are quietly homogenizing how everyone writes. Quiz 1. What kind of task is grammatical error correction, Jack? A sentence classification. Label the sentence as grammatical or not. B. Text-to-text editing. Take an input sentence and produce a minimally corrected output sentence. C. Named entity recognition. Or D. Machine translation into a foreign language. B. GEC produces a corrected string, not a label. That's what makes it different from Video 6's sentiment classification. CoNLL 2014 Ng et al. Formalized this benchmark on English learner essays with hand-corrected gold references. Quiz 2. What is the key difference between GECToR, Canonical et al. 2020, and a Sec2sec GEC model like Yuan and Briscoe 2016? A GECToR only works on English. B. GECToR is a sequence tagger that predicts an edit label, keep, delete, replace, insert per input token, while a Sec2sec model regenerates the corrected sentence from scratch. C. Sec2sec needs no training data. Or D. There is no meaningful difference. They use the same architecture. B. The tagging approach edits tokens in place with a fixed edit vocabulary. Faster and more transparent, but limited on major rewrites. Sec2sec handles rewrites but is slower and can hallucinate. Modern production systems usually ensemble both or route by task type. Quiz 3. Why do keystroke latency writing assistants like Grammarly still ship small local models, even when an LLM beats them on benchmarks? A. The LLMs. Grammar corrections are always wrong. B. Keystroke latency under 50 Ms per user cost, and privacy constraints make full LLM inference impractical on every character typed. So a 2-tier stack, fast local model, plus slow cloud, LLM, wins on product. C. LLMs refuse to correct grammar, or D. Local models are more accurate on every benchmark. B. Benchmark quality is only one factor. Latency, cost, and privacy dominate the product. Modern writing assistants use small local models for confident inline fixes, spell check, common grammar and route, paragraph-level rewrites, and tone adjustments to a cloud LLM. Back to the puzzle. Tagging or Sec2sec, both. And now a 2-tier stack that adds an LLM on top. But zoom out. Writing assistance is quietly homogenizing global English. That's a Lecture 10 conversation. 7 applications down, 3 to go. Next up, text simplification, reading levels done automatically. Next time, text simplification. Making writing more accessible. Reading levels done automatically. Nucella dataset. The accessibility angle. Hit subscribe.